of logarithmic functions. Okay. In regards to review, I want to review the logarithmic function. And the logarithmic function, y equals natural log of x. We'll go with the natural log function. Looks like the following, where this is the value of 1, and it goes right here. So some properties of this function is that the natural log of 1 is 0. Okay. Another property is that the limit as x approaches 0 from the right-hand side of natural log of x is negative infinity. The limit as x approaches infinity of natural log of x is positive infinity. We also have the property that the natural log of e is 1. The natural log of e to the x is going to give you x. So that it does kind of work where the natural log of e, the natural log and e cancel each other out. Now, because of the way the derivative works, most of the times we don't study just the natural log function. We study y equals the natural log absolute value of x. We do this more for a domain issue, because in this function right here, x has to be greater than 0. Over here, x just cannot be 0, because x can be negative. You cannot take the natural log of a negative number. However, you can take the natural log of the absolute value of a negative number, because that gives you, of course, a natural log of a positive number. And this graph looks like the same on the right-hand side of it. It's still 1. And it's just reflected on the other side. The main reason right here, like I said, because now when we talk about the domain is negative infinity to 0, union 0 to infinity. Or over here, the domain was just 0 to infinity. When I show you the derivative of this, the main reason, like I said, when we talk about the domains of the derivative function should be the same as the domain of the actual function. Remember, the derivative function is the slopes. So the slopes describe, the slope function describes the slopes at the corresponding x values. Well, when we look at the derivative of the function, it's a little bit different. So, all right. So, you know, I know there's a lot I can go more into in terms of the evaluation. I did put it on the other one. I mean, I put the evaluation practices with ease and natural logs. I put that more on tomorrow's homework versus tonight's homework on Delta Math. I'm going to open up and release tomorrow's homework today, so that if you are having trouble evaluating and doing the last part of tonight's homework, then you might want to do the first part of tomorrow's homework, which is just on a review aspect of it. That could help you, and I'll send a note out on that, because it's about evaluating ease and natural logs. But I'm really trying to remove a lot of that focus of the evaluation, because, like I said, I feel like there's going to be less of a chance, or less part of no calculators, if we have to work on the evaluations of transcendental functions a little bit more in terms of doing it by hand. I'm anticipating it's going to be open notes for the exam in some capacity. That's my anticipation. It could be wrong. But if we have to, we will do a lot more review. If it changes, otherwise, we'll do a lot more review of evaluating the transcendentals, which is evaluating trig, evaluating natural log evaluating exponents will take a lot more time and review later on in the course. But until I know that information, I don't want to spend the time there, so that we can get through all the material and do it well. All right, so here are your rules. And the first rule, I guess it will still count as a rule. So the rule is that the derivative of the natural log of x is equal to 1 over x. That's the rule. The derivative, now, once again, I could prove that. Technically, the proof of this relies on the proof of the derivative of the exponential function, which is an ugly proof. And then it requires some other type of properties. Like I said, I can prove it. I know why, but I think it's just a memorization for us and for you. All right, just memorize it. More importantly, now, okay, let me go back to this one right here. So when I look at this function right here, the domain here, when I talk about the domain for this right here is x can only be greater than 0. But over here, x is everything except 0. So this is where we have that type of problem where the domain of the function is different than the domain of the derivative. So as such, we typically study the derivative of the natural log of x, the derivative of the absolute value of x. And this absolute value sign throws a lot of students off if you don't pay attention in practice. The absolute value sign does not change the derivative. Now, once again, I could prove to you why, but it requires a derivative of another known derivative, which is called the absolute value function. It has its own special derivative. No reason why to study it in our course, so I don't. But based on that, we can figure out this one. But the derivative is just 1 over x. And this is really is the main one you really want right here. It doesn't matter. The absolute values do not do anything, because it's just the absolute value just fixes the domain, because the absolute value really doesn't change the graph on the right hand side at all. It doesn't do it at all. It just adds the left hand side. Okay? That is your big rule. Of course, we want to understand how the chain rule works. Well, the chain rule works exactly how you would expect it to work. The derivative with respect to x of the natural log of u. Now, let's think about this, and I want your help here. Think about how we change the derivatives with x's and u's. So what do you think the derivative is? And I think that if you've understood how power rule works, if you understood how the trig derivatives work when we're talking about the chain rule, then this rule is exactly the same in terms of following the pattern from the previous one. So let's use our previous derivative that we know right above. And there's a very common property of it, and of course the chain rule. So what is the derivative of the chain rule version? What would you think it would be? Given that the derivative of the natural log of x is 1 over x, what do you think the derivative of natural log of u is with respect to x? Oh, sorry. So couldn't hear you. So sorry, my audio's back on, Ariana.
Maybe it might be 1 over x.
Well, there's no x. There's no x.
1 over. There's no x, so u.
Yep.
Something?
Yep. 1 over u. And then the chain rule part.
And then times the u prime or the dy over dx, something like that.
Yeah. So you can state this as du times du dx. I typically do it that way. Times du dx. So times the derivative of the baby. So I often will refer to this as, and I'll write it on the next one, actually. So that's the chain rule version. But of course, the real one we want to know is the absolute value. So the derivative of the natural value of the absolute value of u is going to be what? Look at the pattern from above. Look at how the relationship worked for the top two. So what's the derivative of the natural log absolute value of u?
Would it just be the same thing?
Exactly. One over the baby times the derivative of the baby. Absolute value does not show in derivative unless is baby. There's a problem such as like natural log of the natural log of the absolute value. Like that has, if the baby is in itself another function that has absolute value, then you could have an absolute value answer, but that's very, very rarely. Basically, you won't see the absolute value in the derivative. Okay. Now, there are rules of logarithmic rules that can help you with derivatives with these logs. Okay. I don't want to spend too much time on those rules, like I said, because we can have a whole 2-day lesson just on the rules of logs and exponents and solving them. I mean, I took a lot of time with that inside my summer program for students who had signed up and who felt that they needed that extra review. And it's something that can help you make easier choices for your derivatives, but it's not a requirement. For example, let's do this example right here. F of x equals the natural log of x times cosine of x. X greater or absolute value of that. Okay, there we go. Find f prime of x. So, what's special about this problem?
Has log on the outside?
Yep, so log, natural log on the outside. And what else?
The absolute value.
Yeah, we can ignore the absolute value. It's not even important really in this problem. It only fixes the domain issue. What else do I know that's kind of important about this problem?
Chain rule? Or?
Yeah, there's a baby. And within that chain rule, what do I notice?
Product?
It's a product rule. So it's a natural log to a chain rule. It's a natural log to a chain rule. Sometimes you have chain rule to a natural log. This is a natural log to a chain rule. So This whole thing right here, I can consider my u. Okay, that's my whole baby. So using the rule that's right above there, and like I said, you just got to follow the rule. And I wrote right here, if you just remember the statement, 1 over the baby times the derivative of the baby. So what do we get? The baby is x cosine x.
Maybe 1 over x times cosine of x. And then you keep the baby, so baby can't, yeah.
And I like to write it like this because the next part, because I know we're still learning. I'll write the x cosine of x again, but then I'll put the little prime times the derivative of that. Some of you may feel very confident doing the product rule right away, but it's kind of like doing a secondary problem. So we need to figure out the derivative of this piece right here, okay? We need to find the derivative of x cosine x. So the derivative, f prime of x, is 1 over x times cosine of x, that's all in the denominator, times, well, what's the rule for the product rule again? Everybody should have this by hand by now.
X cos x.
No, what's the product rule?
The x sine, negative sine x.
No, what is the product rule? Sorry, Ariana, you were saying?
U prime b plus b prime u.
Yes.
Yes.
That is the product rule. Okay. Now, we ask, what is the derivative for this function? And I know we used u for up here. That's why I typically like to call this just the baby part right now. And then when I think about it over here, I think of this as my u and this as my v. So what do we get as our derivative now?
X times
No,
cos.
no. U prime.
Would it be 1 times cosine of x plus negative sine of x times x?
Perfect. U prime. All right, you don't just copy the derivative, the function of the baby. It goes right there. And we got to be very careful like that, because if you don't apply the product rule correctly, then your entire answer is wrong, and that's what happens in calculus. Your entire answer is wrong. So make sure you are practicing and make sure you are doing it correctly every day, and you have to get it correct. And that's the answer. That is the derivative. Okay.
So I have a question.
Yeah.
So why does the x times cosine of x go at the bottom?
Because that is the baby. It's 1 over the baby. 1 over u times du dx. And the times du dx is, so some people will write the derivative of the natural log absolute value of u as u prime over u. So it's the derivative part is in the numerator, and the u, the baby, is in the denominator. So it's times du dx, times where the du dx is in the numerator. Okay, so it's the same thing as if you had 1/5 times 3, that becomes the 3 is in the numerator, or 3 is not connected into the denominator. Like I said, and the rule is always the same. The rule never changes. The pattern of this never changes. So once you get to your 3rd, 4th, 5th, 6th, 7th of derivative of these, it's all the same thing. So I can clean this up. I can clean this up to cosine x minus x sine x over x times cosine of x. And that would be a cleaned up version. This is how you would see it on the multiple choice. But of course, if you're just plugging it in and it just says find a derivative, it's an open response, then you leave that answer like the top. The only part of the quiz that I might add is the cleaning up part. I think that's the main thing that I'm going to be adding, that I'm going to ask you to first find the answer and then explain to me how the algebra works as well. So, yeah, I'm going to do it. Rules of logs can help simplify process of derivatives. It's algebra. Remember, algebra can always rewrite. We can always, when given a function and taking a derivative, we always have the ability to utilize good algebra to clean up the problem to make it a little bit easier, but not requirement. And really, my feeling is that I don't even want you to do it. All right, I don't want you to try to utilize the rules of logs. If there is some reason, a problem that you can only do because of the rule of logs, I doubt that'll happen. And if that does happen, it's not a biggie. It's not really a biggie. It's like the amount of effort and the amount of time, the amount of more knowledge we'd have to add to the course to be able to do that one type of specific problem is probably not worth it. But I do want to note that there's 3 rules of logs. And the first rule says that the natural log, or the log of a times b is equal to the log of a plus the log of b. The second rule is that the log of a over b is equal to the log. Most people get these rules wrong anyways, but I'm going to write them at least, minus the log of b. And the third rule is that the log of a to the x, or a to the b, or a to the n, is equal to n times the log of a. So these are rules for logs, but I don't really feel that you need to memorize these rules. If anything, I feel that for the majority of the students, it'll actually make problems more complicated because you're trying to do it more ways. My purpose in here is that, i.e., when we talked about this problem, natural log of x times the cosine of x, this is the same thing as the natural log of x plus the natural log of the cosine of x. So when you take the derivative now, you get 1 over x plus 1 over cosine of x times negative sine of x. And this is, you can see how the derivative is a little bit more simpler, but it requires you to really not make a mistake in the log rules. And yes, this thing here is equivalent to this here. If I simplify this right here, I get this, all right? They're the same thing. They manipulate down to the same thing. Well, the derivative aspect of this can feel a little bit quicker, and if it really comes down to efficiency. If you're a student who's trying to, if you want to finish the problem as fast as you can, but here's the problem. You still have, if it's a multiple choice problem, you still have to simplify this down because you're not going to see this as your answer. And as such, most likely this problem is going to be a little bit harder to do the algebra afterwards than before. So I wanted to put up that little type of information because it can happen, but I don't really want it to be a biggie in terms of worrying. Okay. Let's do another example. f of x equals the natural log absolute value, and well, I kind of just did it, but cosine of x. Find f prime of x. All right. I kind of did this derivative really for you real quick, but I wanted to at least put it there inside as its own example and to be able to discuss it. This is my baby. So what is f prime of x? Don't rely on
1 over cos of x.
There you go. 1 over cosine of x. Let's finish it.
Times negative sine of x.
Times negative sine of x. And I see Farida had also written that in there. And that negative sine of x is the derivative of cosine x. Now, in my previous example, I wrote times cosine x prime. And then you can do it as a second line. But of course, you want to get a little bit more efficient. And that's the answer. Do you think you're going to see the answer like that on the AP exam? If it's a multiple choice?
No.
No. So you're going to get, so if I simplify this, I get negative sine x over cosine of x. Do you think I'm going to get it like that on the multiple choice?
Maybe, yeah.
Nah, you won't. You're going to get this written as negative tangent of x. So that's one of those problems where, yeah, sine over cosine is tangent. You're like, I don't see any sine over cosine. I see a cosine over sine, so that must be the answer. I see a positive sine over positive cosine, so I must have done something wrong and got the negative sign. And lo and behold, the negative tangent is there as one of your choices. And not only do you have to require the derivative, but you need to require to simplify it, and then you need to know the requirement of the trigonometric relationship. Another example. F of x equals the natural log of x to the 5th power. What do we got? Someone new, come on. Don't rely on the same people talking over and over and over.
Is 1 over x power x.
X and what? What over x what? Your microphone, I think, stopped working.
Can you hear me right now?
Yes, I can.
Okay. It's power 5.
Okay.
Parenthesis.
Where?
The time. Parenthesis. 5x power 4.
There we go. Perfect. Of course, we clean that up and we get 5 over x. X to the 4th over x to the 5th. It gives you just over x. Y equals ln squared absolute value of x. Find dy dx. This one's a little tricky because of the notation. What do I have to recognize about this? What is this really? How can I rewrite this? Chain rule, yeah, it's a chain rule problem to start. And well, so Farida says chain rule. Just want to elaborate a little bit more. It's power chain rule, right? But but I know that's what we think. I think of it as the same thing. I think, oh, it's chain rule first. It's power chain rule first, and then so it's a power rule. It's a power and then a chain. It's a power to chain or power chain to logarithmic. So this is natural log absolute value of x to the second power. So what's dy dx?
It's 1 over
No,
x.
no. It's chain first. That's what we said. We said it's chain. We didn't say it's log. The outside is not a log, so it's not 1 over yet, at least.
2.
2. There we go. 2 times.
Or can you keep everything in the bracket? So like ln power x.
Yes.
And then
Power.
times 1 over x.
Yes. That's it. Times the derivative of natural log of x. Now I put to the 1 power because I subtracted the. You got to make sure that you're doing the rules in the order of the function from the outside in. Now, Darwin could be correct in the way he was saying. He started with 1 over. He technically could be getting to the right answer if he's working from the inside out. But
I don't remember this down to 2.
Okay, but I'm trying to just go over. So he could be correct if he was applying an inside-outside method, but because I haven't taught that, I kind of, insinuated that was, and that's not what I want, at least during my lecture time. I want to make sure that we're doing from the outside in so that we're always doing this common practice. Some people will start with 1 over x, and then they'll do this afterwards. So this will be like over on this side over here, times here. So I do see some students that do it that way from other schools, but that's how their teacher teaches them, inside out. I like the outside in, so we apply this, that's here, subtract 1, and then take the derivative on the outside. F of x equals x squared times the natural log absolute value of x squared plus 1. What's our thinking process? Product, good. All right, so let's do that. So f prime of x equals
2x
2x
time. What is a word that in? Such in?
natural log.
Natural of x squared plus 1.
Careful. Natural log of.
Plus.
No. Natural log of. It's a little tedious part, but if you don't write it, it's a wrong answer. Natural log of. Like I said, it's a little teeny. It's a tedious. It's people just throw it off, but it's the difference between a correct answer and a wrong answer. Natural log of.
Would you use the absolute value?
Yeah, you have to have the absolute value symbol in there, yes. All right, and then the x squared plus 1. Okay, now what's next? What's next?
Would it be 1 over x squared plus 1?
Not yet. Put the brackets here. You're missing something before we get there.
A plus sign?
Yeah, plus 1 over x squared plus 1. If you want to put that in parentheses, you can.
Okay.
What's next?
And then times the x squared?
Not times x squared.
Times... Oh, I forgot to do the inside. Would it be 2x?
And then all that times
the x squared.
Yes. So remember, this is my u prime, that's my v, this is my v prime, and that's my u. And that is the answer. Of course, we can clean it up and say f prime of x equals 2x natural log absolute value x squared plus 1 plus 2x cubed over x squared plus 1. A lot of just come down to just making sure you're practicing. The following rarely shows up on the AP exam beyond one multiple choice problem. So it's kind of a little disclaimer here. Now, in other words, I don't want you to get hung up on this, but if it's on the exam, I'm going to cover it. You are not going to say something like, oh, we didn't do that, and it was on the exam. No, that's not happening with my AP Calculus class. We covered it. All right? But I do know I have a really good knowledge of how the exam is and laid out and the, what they'll do and how often they'll do it. I know some problems are... we might, like the chances that they're going to have a problem like that are super low. We need to cover more material, so we might, gloss over it. That's the kind of thing I'm going to do right here. You have some practice tonight on your Delta Math with the following type of problems, but it's not a biggie. The natural log of x is the same thing as saying log base e of x. These are the same. So when we say natural log, we're referring to the base of the logarithmic as being base e. Okay? Log base e of x can be written in terms of natural logs as the natural log of x over the natural log of e. Well, the natural log of e is 1, so this can be written as the natural log of x. Because this is just 1. Why is that important? That is important because if I do logs of any other bases, then it's also true. For example, log of x is the same thing as saying log base what? When I say log of x, what is the base of the log? Can everybody remember?
U.
No. It's definitely not a variable. It's a number like e. 10. It's log base 10. We're talking about algebra here. So it's log base 10 of x. Following the pattern, log base 10 of x can be rewritten as the natural log of x over the natural log of 10. Why is that important? Well, the derivative, the reason that this is important is because the derivative, or actually let me do one more step, which is the same thing as 1 over the natural log of 10 times the natural log of x. Okay, so that's part. Utilizing this property, the derivative, oh sorry, before I even get there, log base a, meaning any base, doesn't matter if it's 10, doesn't matter if it's e, doesn't matter if it's 5, doesn't matter if it's 2, of the absolute value of x can be thought of as 1 over the natural log of a times the natural log absolute value of x. This is a very important thing because it's a constant multiple. So when the base is not natural log, when it's not a natural log problem, basically you just have this extra 1 over natural log a in front. As such, the rule is that the derivative of the log base a, just any base that's not e, okay, of the absolute value of x is simply 1 over the natural log of a times the derivative of the natural log absolute value of x. Which is of course which is 1 over natural log of a times 1 over x. I don't like this idea of memorizing, like, so where does the natural log of a come from? So a lot of people are wondering that one. The chain rule version is a lot easier. The derivative, or not easier, but it's a little bit more eye-opening. The one that I'm really going to do, natural log base a absolute value of u would be 1 over natural log of a. So what I'm trying to point out is that the 1 over natural log of a, and now a is going to be an actual number, is the only difference. So you do the problem exactly the same, but you add in an extra 1 over natural log of a in front. That's it. Times 1 over u times du dx. And that is the rule. So when you see something that's not natural log, don't freak out. Just go, oh, I just have an extra natural log of a in the denominator. All I do is do it exactly the same, but with a natural log of a, multiply it by 1 over natural log of a. You can do that in the beginning of the problem. You can do it at the end of the problem. You should recognize it's not the same problem as natural log, but it's the same answer with a 1 over natural log of a. Example. F of x equals log base 3 of x squared plus 1. Find f prime of x. Okay, so we see this log base 3. We get freaked out. Oh no, what do I do? This is so complicated. No. Just think of this as 1 over natural log of 3. And you know what? I'm gonna add something. No, I don't want to add. I don't want to confuse right now. Times the natural log of x squared plus 1. That's the same. It's the same thing now. So when I do that and I take the derivative and I say, okay, so f prime of x, well, that's a constant multiple. So my derivative is 1 over natural log of 3 times, now I take the derivative of what I have for the natural log. So what's the derivative now? And we did a natural log at x squared plus 1. So what do I get for my derivative? What's the derivative of that?
1 over x squared plus 1 times 2x.
And that's it. It's the same thing, but it has an extra natural log of 3 in the denominator. So when I clean this up, I get 2x over natural log of 3 times parentheses x squared plus 1 if I want to clean it up and have it written down a little bit more. So when you see a log that's not the same base, that's not just natural log, only difference here of the problem is that you have this extra natural log of 3 in the denominator. I like to think of it as this is the reason why, and some people like to just think of it as this and change it right off the back. Or you can do the derivative like you normally do, okay? And then slap on the natural log of 3 in the denominator, because this is log base 3. Like I said, it's not a major topic. It's not a major thing that's going to make or break anything on the AP exam. It's mostly going to be one multiple choice problem, but you should recognize how to do it. That's what I have for you today. 9:03, we have 2 minutes. Have a good rest of your day.